Hello. Today we're going to calculate the mass of a black hole by looking at observational data of a star that is orbiting a black hole. On the left side I will guide you step by step, and at the same time on the right I will show you the code on VPython. My initial data given were the mass of the star, the position of the black hole, and the time step between observations. We can see them here: the mass of the star, the position of the black hole, and of course delta t. The positions of the star were taken from this file, which is saved on my computer. So how do we calculate the mass of the black hole? It's very simple. We begin from the gravity formula, where m1 is the black hole mass, m2 is the star mass, and there is also the constant g. Then we solve for m1. In order to do this, we first have to find fnet. So we take the first three positions of the star, we calculate the initial velocity, then we calculate another velocity after that, then we take the momentum initial and the momentum final, and we calculate fnet, which is delta p over delta t. We can see also here on VPython initial velocity and final velocity, the momentum, the changing in the velocity and the momentum, and of course fnet delta p over delta t. Let's run now a program to see the orbiting. Okay, very good. Let's move this. This number is the mass of the black hole. Okay, here it is the result. It seems very good. Now we can see here that there is a parallel force and a perpendicular force. For the parallel component, we take the unit vector of the momentum and multiply it by the changing in magnitude of the momentum over changing time, as we can see here. The parallel component describes the acceleration and deceleration. The perpendicular component comes out by subtracting the parallel component from the total net force. But what does it mean? We have to be careful, because fnet is not equivalent to the changing in the momentum over changing time. We know that the force is the cause, and the observed changing in the velocity and therefore the changing in the momentum are the effect. On the calculation we assumed that they were equal, but in reality there is only an approximation. What if we replace the black hole mass with another, and the motion of the star remains unchanged, and the only force exerted on the star is a gravitational force? Is there a different mass from for the black hole? The answer is no, because we would see a change on the orbit of the star, which is not happening, of course. Thank you very much.